This 23-story building, the problem statement given by the skyfi lab. Here you can see the different stories option for 1 to 8 story, 9 to 14 story, 15 to 19 story, and 20 to 23 story. You have to use beams and columns mentioned here, a slab of 150 mm thick and M40 grade of concrete. Auto draw cladding to be used with the cladding load of 0.2 kN per meter square and wind load to be considered. In parameters to be used in Bangalore. Open the ETAP software, go to the file, click on the new model. Use this as given here, metric SI Indian IS 800 2007 456 2000. Click on OK. Showing the spacing as 6 and 6 in both x and y direction. In the story to 23. Typical story height is 3 and 3. Custom story data to be used. Edit story data. The first 8 stories are similar, so I am changing 8 stories as master story, changing the other stories to similar to story 8. And the 9 to 14 stories are similar, so I am selecting 14 story as similar story. You can select any one of 9 to 14 story as a master story. Similar to 14 story I am changing here. Once I am done with this, I am changing 19 to 14 story as similar. 14 to 19 story as similar. So 15 to 19. And other 20 to 23 stories are similar, so I don't need to change here. You click on OK. Select read only option and click on OK. Here you can see the building is here. Now we have to define the properties. Go to the define menu, select material properties, add new material, select region as India, change to the concrete, standard as Indian, select M40 grade of concrete. Click on OK. Add new property, change material property to rebar and grade HYSD 450. Add new property, change the grade as to minus 250. Now we have to define the frames. Go to define, select section properties, select frame section, add new property, select concrete rectangular section, give the appropriate name. Since we have to design 3 different types of column, change the material property to M40, mention the depth and width, select modifier show rebar, then change longitudinal bar as HYSD 415 and tie bar as -215. Leave the other data as same. Again click on OK. Go to the copy of the properties because I have to define all other 2 columns with the same property. So I'm going to copy of the property, then give the name, just changing the depth and width, and I'm done with this. Click on OK. Add a copy of the property, give the name, change the depth and width, click on OK. Since we have to auto select this, add new property, select auto select, give the name, auto select column, change the auto select design type as concrete, select these three columns, click on add, then click on OK. To add new properties, since we have to define the beams, select concrete rectangular section, give the name, change the material property, change the depth and width, modify show bar. Now you have to choose a3 design only, since IS 456 2000 says that the cover for 25 mm, change longitudinal bar as HYSD 450 and lateral bar as mine 250. Click on OK. Then again click on OK. Add copy of the property, change the name, change the depth and width, click on OK. Add copy of the property, give the name, just change the depth and width. Then merge this as auto select, add new property, auto select list, give the name, change the type as concrete, select these three beams, click on add, and click on. Now we have to define the slab. Go to the define menu, select section properties, and then slab section, add new property, give the name, just change the change the slab material to M40 and thickness to 150. Then click on OK. Now we are done with the defining properties. Now I am going to design the building. So select the similar story option. By clicking by using up and down arrow or selecting here, you have to go to the first story. Now I am on the very first story. Okay. Now going to go to the draw menu, withdraw column option, change the property to the auto select column, select the area. You can see here the columns are drawn. Go to the draw menu, select withdraw beam option, change the property to the auto select beam. It will select appropriate beam for this section. And go to the draw menu, select the draw floor option, then click draw floor, change the property to we have defined before, just select the areas and the slabs are here. Now go to the next type of similar story. I'm going to the 9th story. Go to the draw menu, click draw column, just draw the column given in the problem statement. Shape before similar stories is selected and make sure the similar story option is selected. click on draw menu, select quick draw column, property is selected to the auto select column, and select the area to draw the column. Again go to the draw menu, and select quick draw beam, draw the beams. Now go to the draw menu and select quick draw floor, draw the slabs. Now I am going to the next type of similar story by clicking here, or by you can use up and down arrows. Go to the draw menu, quick draw column, select the area and draw the column. Again go to the draw menu, select quick draw beams, and draw the beams. Now again go to the draw menu, select quick draw floor option and draw the floor. Now go to the next type of similar story by clicking here, or you can use up and down arrows. Okay. Go to the draw menu, use quick draw column, draw the column. Again go to the draw menu, select quick draw beams, draw the beams. Then go to the draw menu, select quick draw floor or wall objects and draw the floors. Here we are done with the drawing of column, beam and slab. Now we are going to assign the load. Go to the first story, select all stories options from here and select all the shells. Go to the assign menu, select shell loads, select uniform. Change the load pattern to dead and assign the dead load of 2 kN per meter square to all the stores. Click on OK. Now select similar story option, select the shells, select the shells, go to the assign menu, again shell load, uniform, change the load type to live load and 5 kN per meter square of live load applied and click on. Here you can see. Go to the next type of story, select the shells, go to assign, select shell loads, select uniform, live load of 4.5 kN to be applied as given in the problem statement. Here you can see it is applied. Go to the next type of story, select the shells, go to the assign, shell load, uniform, again you have to apply 4 kN per meter square of live load, applied, and then click on OK. Now go to the next type of story. That is 23rd story I am doing here. You click on apply. Click on OK. Select the shells. Go to assign shell loads. Here I am facing some problem with the I didn't select it. I have to select similar story. Select the story. Then go to the assign menu. Shell load. Uniform. Simplify. Apply. Then click on OK. Now we are at the 23rd story. Go to the one story option. Select the shell. Go to assign shell loads. Uniform. Delete existing node. Select the apply. So it's the 23rd story didn't have any node. So we are done with this. Now go to the first base story. Go to the select the base story. Go to the assign menu. Select the joint, restraints. Select the fixed restraint. Click on apply. I have edited select the area because I'm selecting the area here. So go to the assign, join, restrain. Now click on apply. Click on I have restrained all these sections. Now go to the draw menu. Select auto draw cladding, use close, and click on OK. You can see that your building is ready. Now we have to apply wind load. For the wind load, consider the wind is blowing from that is from section A and B. Go to the define menu. Select load patterns. Change the load pattern to wind load. Type to wind. Select the IS 875 1987. Click on add new load. Go to the modify lateral load. You have to refer IS 1875 part 3 and open the map. I am opening the hard copy, so I am not showing here. I don't have the soft copy of that particular ISO. So open the map and consider the building to be designed in Bangalore as given in the problem statement. So we have to define the wind speed of 33 meters per second. Okay, and the terrain category you can use clause 5.3.3.1 from the IS 1875 part 3. The terrain category is 3 and the structure class is C. You can buy the height of building is considering 50 meter, so it is C. So risk coefficient is 1 and the topography K3 factor is also 1. You can refer IS 1875 part 3 since we are considering that design life of the building is 15 years. You can use the IS. Then click on OK. Click on OK again. Now go to the elevation option, select the A, click on OK, select all stories option, select the shells. You can see table 4 from the IS 1875. As it will give the different loading options. Now go to the assign, go to the assign, shell loads, click on wind pressure coefficient, change the coefficient to plus 0.8 as mentioned in the IS. Click on apply, then click on OK. Again go to the elevation option, select the section B, click on OK, select all the shells, go to the assign, shell load, wind pressure coefficient, and the wind pressure coefficient is 0.8 again. Click on apply, click on OK. Sorry, it is 0.8. So here wind load is applied to there. Now go to the elevation section, select section D, click on apply, click on OK. Select the shells, go to the assign, shell loads, wind pressure coefficient, lever side minus 0.2. Click on apply, and then click on. Again go to the elevation, select the section C, click on OK, select the shells, go to the assign, shell loads, and pressure coefficient 0.25, lever diagram. Click on apply, click on OK. Now go to the section 1, click on OK, select all the shells by select the shells of them. Again go to the next story, select the shells of them, story, next fourth side, select the shells. Go to the assignment, select shell loads, click on wind pressure coefficient, and here the wind pressure coefficient is 0.8. Click on apply, again click on apply. You can see the loads are assigned here. Now go to the 3D view tab. I'm selecting here this 3D view. So here are my 3D view and here the my plan for the first story. Here is the load assigned. Choose this option. Use excerpted use shell output. can see. Now go to the design, analyze option, and click run and analyze. Here the software is analyzing the building. Wait until it analyzes. You can see the progress here. The analyzation is completed. You can see the values of this and also display. You can go display, deform shape. You can sorry, you can go to the display, more stress diagrams and select frame here. You can see shear 2 to 2. You can see the SF and BM of this. Here is SF, sorry BM, shear 2 to 2. Here is shear force. So now it's time to final design. Go to the concrete frame design. Your revised preferences as mentioned here with the IS456 tools. Click on OK. Go to the option design, concrete frame design, start design check. It is design. The design check is finally completed. It's not seems. Wait until it designs. Now go to the design menu, concrete frame, and verify all members passed. So all members are passed. If you have the ATABS 2016 option, you have here the detailing option, but I am using to ATABS 2018, so it is not detailing option here. You can see the reports, project report. Double click on this, and it is preparing the project report for me. It prepares the recording uh, project report for me. You can see here. You can also see summary report. Let's put